Good afternoon, students. I have already given you 2 lectures on sampling theory. In those 2 lectures, first lecture was test of mean for large sample and second lecture was test of difference of mean for large sample. Now, in this lecture, we will discuss this test related with small sample. Now, we already know that small sample means the size of sample is less than 30. Now in small sample test, our first test is called t-test for mean. And this test is if x bar is the mean of sample, mu is the mean of population and s is the sample standard deviation, then test statistics is t equal to x bar minus mu divided by s divided by under root of n minus 1, where value of s is under root of summation of xi minus x bar square divided by n. Has the student t distribution with nu equal to n minus 1 degrees of freedom. So this is called t-test for small samples. So one important note is here. So if values of x are given, we can find out x bar equal to summation of x by n. Another formula is also there, x bar equal to a plus summation of di by n, where di is deviation of xi from some number a. So when we have to use these two formulas, that is the question. So when values of x are small number, we can directly find out mean of x, that is x bar. But if values of x are given which are big numbers, then we will use this formula. Now next formula is s square equal to summation of x square divided by n minus summation of x whole square divided by n. So there is a difference between these two terms. Remember this difference. This is first take square of all the values of x and then take its summation. Here first take the summation of all values of x and take its square. And last formula is summation of xi minus x bar square equal to summation of di square minus summation of di whole square by n. So we are see here. So in finding value of s, we require the summation of xi minus x bar square. So we can find out this term using this formula. So consider one example. The mean lifetime of a sample of 25 bulbs is found as 1550 hours with a standard deviation of 120 hours. The company manufacturing the bulbs claims that the average life of their bulbs is 1600 hours. The question is the claim acceptable at 5% level of significance? So just observe the example. What are the given things? So here sample size is 25, so value of n is 25. Sample mean is 1550 hours, so x bar is 1550. Also sample standard deviation is 120, so s is 120. And I have to check whether the mean of the sample is 1600 or not. So mu is 1600. So we have to test null hypothesis H0 as mu equal to 1600 and alternate hypothesis H1 which is defined by mu is not equal to 1600. So here the samples is of size 25, so we have to use small sample test. So t equal to x bar minus mu divided by s by root n minus 1. So value of x bar is 1550 minus value of mu is 1600 divided by 120 divided by under root of 25 minus 1. So after calculations you will get this value minus 2.0375. So mod of t calculated, that is positive value of t calculated, is 2.03. Now in previous test we are considering just at 5% level of significance, but in t-test we are using one new symbol which is called nu and its name is degrees of freedom. In Z test we are using just level of significance, but here we are using level of significance as well as degrees of freedom. So at 5% level of significance with nu equal to n minus 1, which is 24 degrees of freedom, tabulated value of t is. Now how to obtain this value? So this is the table we have already given with our workbook or question bank. So first column is degrees of freedom. Now in this example we have to check tabular value at 24 degrees of freedom. So 24 degrees of freedom means here, and with 5% level of significance means this is 5% level of significance. So 24 degrees of freedom with 5% level of significance is 2.06. This is the value. So here t tabulated is 2.06. So calculated value is less than tabulated value, so H naught is accepted. So meaning of H naught is accepted is, therefore the claim of company, that is average life of their bulbs is 1600 hours, is acceptable at 5% level of significance. Now consider the second example. 10 individuals are chosen at random from population and their heights are found to be 63, 63, 64, 65, 66, 69, 69, 70, 70, 71 inches. Discuss the suggestion that the mean height of the universe is 65 inches. Now in a sample there are 10 individuals. So example is of small sample. Now given things are n equal to 10 and mu equal to 65. And values of x are given. So first we will find out values of x bar and s. So first row is values of x. Now here we will consider di, which is called deviation of x from some number. So here di equal to x minus 66. You can consider any number in place of 66. As values are large, so we will consider another formula for finding x bar. So di equal to x minus 66 and di square. So when x is 63, so 63 minus 66 minus 3 and its square is 9. Second value of x 63 minus 3, 9. 64 minus 66 minus 2, its square is 4. 65 minus 66 minus 1, square is 1. 66, 0, 1. 69, so 69 minus 66, 3 and the square is 9. 69, 3, 9. 70, 70 minus 66, which is 4, 16. 4, 16 and 71 minus 66, 5. Its square is 25 and total of all di's are 10 and di square 98. Now we know this formula, x bar equal to a plus summation of di by n. So which is 66 plus summation of di is 10 divided by 10, which is 67. Now summation of xi minus x bar square, which is equal to summation of di square minus summation of di whole square by n. So summation of di square is 98 here minus summation of di is 10, its square 100 by 10, so which is 88. Therefore s square equal to summation of xi minus x bar square by n, and this summation is 88, so 88 by 10 equal to 8.8. Now we know values of x bar, we know value of s, we know mu, we know n. So to test null hypothesis to be mu equal to 65 and alternate hypothesis h1, which is defined by mu is not equal to 65. So using t-test, t equal to x bar minus mu divided by s divided by root n minus 1, which is 67 minus 65 divided by root of 8 minus 8 divided by under root of 10 minus 1, which is 6 divided by 2.97, which is 2.0. So t calculated value is 2.02. Now level of significance is not mentioned, but 5% level of significance with degrees of freedom equal to n minus 1. So n is 10, so 10 minus 1, 9. So tabular value of t. So see here, at 9 or degree of freedom 9, at 5% level of significance, value is 2.26. So this is 2.26. So here calculated value is less than tabular value, therefore H naught is accepted. And H naught is accepted means the mean height of the universe is 65 inches.